Since we're most familiar with natural number exponents, that is, counting number exponents, let's start with that. 3 to the fourth is 3 times 3 times 3 times 3, which is 9 times 9, or 81. 3 times 3 times 3 is 27, 3 squared is 9, and 3 to the 1 is 3. Those are the easy ones. And what you'll notice is that as we go from number to a higher exponent, we multiply by 3, multiply by 3, multiply by 3. If we go in the opposite direction, we're going to divide by 3. So if we keep dividing by 3 to get the next number, 81 divided by 3 is 27, 27 divided by 3 is 9, 9 divided by 3 is 3, 3 divided by 3 is 1, 1 divided by 3 is 1/3, 1/3 divided by 3 is 1/9, and 1/9 divided by 3 is 1/27. What I want you to notice is that, for instance, 3 raised to the positive 3 and 3 raised to the negative 3 are reciprocals of one another. Let's see if the same thing holds true for powers of 10. For powers of 10, 10 to the fourth is 10 times 10 times 10 times 10, which is 10,000. 10 to the third is 10 times 10 times 10, which is 1,000. Squared is 100. 10 to the 1 is 10. If we want to continue using that same pattern, we'll divide by 10 to get the next number, which gives us 1. Divided by 10 is 1/10. Divided by 10 is 1/100th. Divided by 10 is 1,000th. So a couple things come out of this. That is that whenever we raise a number to the 0 power, it's equal to 1. And then when we raise a number to the negative n power, that's the same thing as 1 over the number to the positive n power. Those are all true for non-zero numbers, since we can't be dividing by 0. All right, so let's work a couple of examples. 2 raised to the negative 4 power is going to be the same as 1 over 2 to the positive 4 power. 2 to the positive 4 power is 2 times 2 times 2 times 2, which is 16. So final answer, 1/16. 7 to the 0 power is 1, because any number raised to the 0 power is 1, provided the number is non-zero. And 5 raised to the negative 3rd power is 1 over 5 cubed, which is 1 over 5 times 5 times 5 is 1/125th. All right, try A below on your own and pause the video. All right, you should have gotten 1. Now try B. The answer for B is 1/27th. Now try C. The answer for C is 1/64th. All right, let's keep going. Now we're going to look at some fractional values, and we're going to use all of our fraction skills. So 1/3 raised to the negative 4th would be the same as 1 over 1/3 raised to the positive 4 power. And that would be the same as 1 over, and that would be 1/3 times 1/3 times 1/3 times 1/3, so 1/81st. Remember that a fraction means divide, so this is 1 on the top divided by 1/81st on the bottom, which is the same thing as 1 times 81, which is 81. All right, if we want to do 6/7 to the negative 1, that would be 1 over 6/7 to the positive 1, which is going to be 1 divided by 6/7, which is the same thing as 1 times 7/6. So that answer is going to be 7/6. 3/2 raised to the negative 2 is 1 over 3/2 raised to the positive 2, or 1 over 9/4, which means 1 divided by 9/4. Same thing as 1 times 4/9. So that answer is going to give us 4/9. Now what I want you to notice is all of these could have been done by simply taking the reciprocal of the original number and then raising it to the opposite power. So for instance, 1/3 raised to the negative 4 would be 3 raised to the positive 4. 6/7 raised to the negative 1 would be 7/6 raised to the positive 1. 3/2 raised to the negative 2 would be 2/3 raised to the positive 2. So whenever we have a fractional base, what you can do is you can make a over b to the negative n the same as b over a raised to the positive n. All right, why don't you try a couple of those, and you don't have to do all the steps that I did. You can use that shortcut. So pause the video and try a. All right, you should have gotten 9/4 for a. Now pause the video and try b. B should have given you 64. All right, now try C. The answer for C is 125/8. And let's move on. Now we're going to work with variables, but I want you to think of them as the same as you would numbers. So for instance, in A, in example 4, anything raised to the 0 power, assuming that it's a non-zero number, should be 1. C raised to the negative 3 can be simplified using a positive exponent, making it 1 over c to the 3. K raised to the negative 1 is 1 over k raised to the positive 1, which in simplified form would just be 1 over k, since k to the first power is just k. In D, we have a fraction raised to a negative exponent. And remember how we handled that. You're going to take the reciprocal, b over a, and replace it and raise it to a positive exponent. So that's going to give you b to the 4th over a to the 4th. Same thing for E. 5 over n raised to the negative 2 is the same as n over 5 raised to the positive 2. Remember, that's n over 5 times n over 5. N times n is n squared. 5 times 5 is 25. Now, last one. That's 3 over 2w raised to the negative 3. So that's going to be 2w over 3 raised to the positive 3. For this one, I would encourage you to write this out. When you raise something to the 3rd power, that's the same as multiplying it by itself and then by itself again. So that's going to give us a final result of 8w cubed over 27. A lot of times when we have multiple factors, sometimes folks forget to raise that 2 to the 3rd power as well. All right, and in G, x to the negative 2 raised to the negative 3, I want you to think of this in terms of order of operations. So we're going to take care of the stuff on the inside of the parentheses first. That's 1 over x squared raised to the negative 3rd power. Now remember, when we raise a fraction to the negative 3rd power, that's the same as raising its reciprocal, x squared, to the positive 3rd power. And remember that x squared raised to the 3rd power means x squared times x squared times x squared, which is equal to x to the 6th. All right, in H, u to the negative 1 on the inside of the parentheses is 1 over u, but that whole thing is raised to the 0 power, so that's going to be 1. In I, we've got a raised to the negative 4th power, which is 1 over a to the 4th on the inside, raised to the 3rd power. Now, beware, that outside power is not a negative power, it's a positive power. So that just means repeated multiplication, which means 1 over a to the 4th times 1 over a to the 4th times 1 over a to the 4th, which would be 1 over a to the 12th power. All right, why don't you try a below on your own? You should have gotten 16 over n to the 6th. Remember that n cubed squared is the same as n cubed times n cubed. And n cubed times n cubed is n times n times n times n times n times n. So now there are 6 factors of n. All right, try b now on your own. b should have given you 9n squared over 16. Notice that this one did not have a negative exponent in it, so it just means repeated multiplication. All right, last one is c. Try that one on your own. And that should give you k to the 10th power. That ends the first part of this lesson. Now you can try the first part of the practice.